So let's now create our particle simulation. First of all, let's add a null just after our delete node. Let's change its color and call it out ink bubble emitter. Again, press the tab key and look for a pop network. So this pop network we can connect just after the null. Just make sure it is on the first input. And let's call this node pop ink bubbles. Let's change its color. And let's go to frame 1. So dive inside the pop ink bubbles node. And let's spread these nodes apart just a bit. And also let's take a look at the source node. Let's see what's happening here. So the emission type by default is using scatter onto surfaces. Currently our input doesn't have surfaces, it's only points. So change the emission type to all points. And let's press play just to see what's happening. So notice these blue points are the emitter we just created. And of course we have new points being created, but they're static currently because we don't have forces or anything to move them. So what I'm going to do first is create some forces to emulate the buoyancy of the water. Just as we did with the volume, we want these bubbles to rise. So let's do that first. Let's go back to frame 1. And I will add a pop force node. I will change the name of this node to buoyancy. And I want it to be a very subtle force. So here on the y component of the force parameter, let's type 0.2. And let's start with this. Let's press play and see what's happening. So notice how this value of 0.2 is enough to bring the bubbles upward. Now there's something that I really don't like. Notice how we have some banding, some horizontal lines are becoming clear. So what I'm going to do to avoid this, and I usually use this technique when I'm creating particles, I'm going to create a mass property and randomize the values of this property. So I can do that with a pop property node. So I'll connect it here on top of the buoyancy node. I'll call this node set mass. And notice here under the properties, we can turn on the mass attribute. So this is creating an attribute. Once you've turned this property on, you can scroll down and click here, use the expression. Scroll down, and here on this arrow to the right, you will find a randomized mass expression. So just click here and the VEX code will be created for you. Now what this code is doing is adding values ranging from 0.7 to 0.1 for the mass attribute. So if you want the randomization to be higher, you can decrease this value, say to 0.2. And now under the forces, every time you add a pop force, make sure to turn off this option, ignore mass. And that way the mass of each particle will be multiplied by this force. And since we currently have randomized values, the force will be slightly different for each particle. So if you press play, the banding should be less apparent. And in this case, it's practically gone. So I think I'm happy with this. Of course, the main thing here is we want the bubbles to be advected by the ink. We don't want them to just rise upward. We want them to move with the ink to have a very natural motion. So let's do that. I will now add a pop advect by volume node here. And I will connect it just below the buoyancy. I will make some more space here. So what this node will expect is a velocity volume. So let's go back to the object context, dive into the ink geometry node, and remember we created this out ink null. So this is outputting the density, the color, and the velocity. We need this vel volume to advect the particles. So let's copy this null, Control C to copy. Let's go back to our simulation. Select the pop advect node, and here under the SOP, paste the node that we just copied and press enter. And make sure the volume name is correct. So we did confirm that the name was vel. So usually the default is fine. Now, something that I usually change is the advection type. So currently the advection type is set to update force. I'm going to change this to update velocity. So the difference is update force would act similar to the wind or gravity, where each frame the velocity is incremented slowly. And here with the update velocity, the change in velocity is much more abrupt. So the motion of the particles will match much more closely the velocity of the volume. So let's see how this works. If you press play, you should now see some very nice motion of the bubbles following the volume of the ink. So let's turn on the ink. This way we can see them both together. So here on the top right, let's make sure to select Ghost Other Objects. And let's see if the ink is on. Yeah, so here you can see the bubbles that are being created should match the motion of the ink. So let's create a flipbook real quick. Okay, so I've catched a few frames, and notice how the bubbles have this very nice motion. One thing that I really want to fix is we still have bubbles near the edges, so we might want to clamp the density a bit more. And of course, we currently have a huge amount of bubbles. We will reduce the overall amount of bubbles in the final render. So let's take care of this. Let's go back to our particle simulation. So first of all, let's clamp the density. Don't forget to hide the rest of the object. So I can probably go to 0.99. That should be enough. I will also reduce the amount of scattered points to 10,000. I think we can go with this.